Hey guys, I hope you're ready to have a good weekend. We're going to go ahead and now we're getting into permutations and combinations, which are a form of probability statistics type stuff. So let's go ahead and start looking at that. Um, First thing you need to know is called the multiplication counting principle, and it's real simple. It's if there are m ways to make a first selection and n ways to make a second selection, then there are m times n ways to make the two selections. Okay? Some of this is going to make more sense as you see problems with it on there. But if you look at permutations is just very simply an arrangement of objects in a specific order. Okay, that's the key with a permutation, is it requires a specific order. All right. If it's a permutation, it's using the formula NPR, where N is your total number of items, R is how many you're choosing at a time. That's going to equal n factorial over n minus r factorial. Factorial is the product of the integers from n down to 1. So let me just give you a brief example. If I say 3 factorial, that's 3 times 2 times 1, which is going to be 6. Okay? If it was 7 factorial, it would be 7 times 5 times, 7 times 6 times 5 times 4 times 3 times 2 times 1. All right? So, combination is a selection of objects without regard to order. So in a combination, order doesn't matter. In a permutation, it does matter. Okay, so for a combination, it's n items being chosen at r at a time, and that equals n factorial over r factorial times n minus r factorial. And let me make sure that you see this is an exclamation point right here. Okay, on both of these, that is an exclamation point. Okay, so when you're doing these problems, the first thing you need to decide is, well, is it just multiplication counting principle? Is it a permutation or is it a combination? Okay, so for example, you decide to watch 3 movies at home in a row. You have a comedy, a drama, and an action movie to choose from. How many different ways or orders for watching the movies are possible? Okay, well, when I look at this, I'm not taking a large group and then choosing a smaller group out. I'm dealing with an entire group here. I'm not, like I said, I'm not choosing a smaller group out of it. So this is going to be a multiplication counting principle, okay, because I'm taking into consideration all 3 movies. All right, so the first choice then, you would have movie 1, and that's a terrible M. So you would have movie 1. Well, how many choices do I have to watch it first? Well, for the first movie, I could watch a comedy, I could watch a drama, or I could watch an action. So I have 3 choices. Okay? For movie 2, I have, well, if I watch one of them for movie 1, that means I only have 2 choices left. So I have 2 choices to watch here. And then for the final movie, well, if I watched one of the movies the first movie and I watched one the second movie, if I only had 3 movies to watch, that means I only have 1 choice here. So I'm going to multiply all 3 of these choices together, and I'm going to get that there are 6 possible ways to which I could watch those 3 movies. Okay? Let's actually write down a few so you can see. So I could watch a comedy first, a drama second, and an action third. Or I could watch a comedy first, an action second, and a drama third. Or I could watch a drama, a comedy, an action, or a drama, an action, then a comedy. So there's 4 of my choices. The last 2 are action, comedy, drama, or action, drama, comedy. There's all 6 of my ways. Doesn't matter how many other ways you look at it, these are the only 6 different ways that you can watch those movies. Okay? So this is an example of multiplication counting principle. Example number 2. A band has 7 new songs and wants to put 5 of them on a demo CD. How many different arrangements of those 5 songs are possible? Okay? So, when you're dealing with putting music on a CD, aren't you dealing with an order? I mean, you don't just like throw them all on there and they just randomly play. Okay? You throw them on there, they're in a specific order. So this is an example of when order matters. So this is going to be what we call a permutation, which is going to follow NPR, which is n factorial over n minus r factorial. So once we determine whether it's permutation, combination, or a multiplication counting principle, now we need to decide what is n and what is r. Well, n is the total number of items I have, okay? And the other thing is when you look at this, we know that this is either a permutation or combination because I have 7 songs total. I'm taking 5 of them out, okay? So unlike the last one where we were dealing with all of the items, I'm only dealing with 5 of these at a time, okay? So n is the total number of songs, which is 7. R is how many I'm taking at a time, which is 5. So now all you're going to do is plug it into the formula. So it's 7p5 equals 7 factorial over 7 minus 5 factorial. Okay? So, how this works is 7 times 6 times 5, 4, 3, 2, 1, over 7 minus 5 is 2 factorial, which is 2 times 1. Well, when I do the division here, the first thing I can do is I can cancel. I can cancel these, which then leaves me with 7 times 6 times 5 times 4 times 3. And when I multiply those together, I get 2,520 possible arrangements. Okay? Seem fairly easy? Doesn't seem too bad to me. Alright? So, let's go to example number 3. Again, first thing we need to do, we need to decide permutation, combination, or multiplication counting principle. Okay? So, 20 people report for jury duty. How many different 12-person juries can be chosen? Alright, so I'm taking a big group and I'm taking a smaller number out of it. So it's not multiplication counting principle. Okay? So I know it as a combination or I know it as a permutation. So the next question we have to decide is, does the order matter? So if I have 20 people and I'm taking 12 people out, and I'm making a jury, does the order of that jury matter? No, it doesn't matter. You're just taking 12 random people out. Okay? So since order does not matter, this is a combination, which is NCR. That is n factorial divided by r factorial times n minus r factorial. So again, first thing, we decide permutation, combination, multiplication counting principle. We did that. Now we're going to decide n and r. Okay, so n, total number of people in this case, which is 20. R is the amount I'm choosing at a time, which is 12. So now let's fill in the formula. So you have 20C12 equals 20 factorial over 12 factorial times 20 minus 12 factorial. Okay? So 20 factorial over 12 factorial times, well, 20 minus 12, I'm actually going to get rid of my parentheses here. is 8 factorial. Okay? Now I can't just combine these. All right? So now this is when it can get a little bit more sloppy. So I'm going to write 10, 20, 19, 18, 17, 16, 15, 14. Actually, let me go ahead and do that down here. Give me a little bit more space. Okay. Now, times dot 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 times 1. So the dot 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 means that the pattern continues down to 1. Okay? Now, I have 12 factorial, which is 12 times 11 times 10 times dot 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 times 1. Okay? Times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, just like on the last one where we canceled, I can cancel here too. And the suggestion is to always cancel with the largest factorial on bottom because it gets rid of the most on top. So I know 12 factorial is 12 times 11 times 10 times 9 all the way down to 1. So I'm going to cancel this with 12 all the way down to 1. Okay? That is then going to leave me with 20, 19, 18, 17, 16, 15, 14, 13 over 8, 7, 6, 5, 4, 3, 2, 1. Okay? So now I have some stuff left. I'm going to go ahead and do some more canceling. For example, 5 times 4 is 20. 20 will cancel with 20. Okay? I have 8 will cancel with 16. The 8 becomes a 1. The 16 becomes a 2. I have that 7 and 14 will cancel. 14 becomes 2. 7 becomes 1. 6 times 3 is 18. That'll cancel with this 18. Now I have this 2 and this 2 will cancel, and the 1 cancels with everything, so it doesn't matter. Okay? So now what I have left, I only have 1 on the bottom. Now I have 19 times 17 times 2 times 15 times 13 divided by 1. And now I have at least a lot smaller numbers to work with. So 19 times 17 times 2 times 15 times 13 is going to be 125,970. Okay? So, out of those 20 people, how many different 12-person juries could I come up with? I could come up with 125,970 different 12-person juries. And now remember, I'm not taking 12 people at a time and keeping those 12 people out. I'm taking 12 people, I'm writing them down, putting all the people back. I'm choosing 12 different people. Okay? Some of them will overlap, but no jury is going to be identical to another one. There are 125,970 different 12-person juries. Okay? Example number 4. There are 52 players on a high school football team. 4 of the players are freshmen, 18 are sophomores, 16 are juniors, and 14 are seniors. 2 players are chosen at random to go first during the drill. The order the players are picked is important. What is the probability that both players picked are freshmen? Okay? So, in this case, we are going to end up having to figure out how many different ways there are to choose them, so how many different outcomes are possible, and then we're going to have to figure out of those different ways, how many different ways is it possible to pick 2 freshmen. And then you divide the 2. Okay? For example 5, 12 singers are auditioning for 9 spots in a choir. In how many different ways can the singers be selected for the choir? Those are your 2 examples. Those are the 2 you're required to do for Monday for your warm-up. All right, have a great weekend, guys. I will see you on Monday.